Right, it's new topic time. It's circular functions, the name of our new topic. And so I've drawn quite an impressive freehand circle there, I think you'll agree. So in this area, circular functions slightly anti-intuitive in that circular functions are all to do with things that you will think of as trigonometry, sine, cosine, that sort of stuff. But we're gonna look at it in the context of a circle and a unit circle. But firstly, before we get too heavy into that, we're gonna investigate what radians are, because this is a new way of measuring angles. It's an alternative to degrees. So of radians, alternative measure of angles to degrees. Now you'll be comfortable with degrees. You probably won't see that there's much of a need for an alternative measure. But let's have a look at it anyway, because we need to know. And in fact, there's a good argument for using radians. Okay, so there's the center of my circle. All right, and I'm going to draw a little radii out here, and that's 1 unit in length. Now, what I'm going to do here is I'm going to say this is what's called a unit circle, because it's a circle with a 1 unit radius. Okay, so unit circle. This is my unit circle. All right. So what I'm going to do here is I'm going to, right, so it's got a radius of 1. I'm going to go around the circumference of the circle until, tell me when to stop. My length there is the same as the length there. So in other words, this little arc length around the circumference is 1 unit long. When it is, and I reckon that's about it there, isn't it? All right, close off this sector now, and what we've created at the center here is an angle of 1 radian. So the thing to first acknowledge about radians is that they are length related, arc length related. They're related to a length. If you think about degrees, what on earth are they? Now, 60, 120, 360 degrees in a circle, it's pretty random. And actually, the theory is that a number, a full rotation of 360 was used just because it's a factor-rich number. So many numbers go into 360. 60, 45, 90, 180, 30, did I mention 30, 15, 10, 12. There's so many factors of 360. So that's why it's thought that 360 was used as a full rotation of degrees. But it goes way back to navigational days. It's probably not so much of use to us anymore. Radian's really useful. Look at that. 1 radian here. This angle here is relative to that arc length there. So 1 radian is defined as the angle at the center of a circle, center of the unit circle, that subtends an arc length of 1 unit. Wow, that's a good sentence. Let's write that down. 1 radian is the angle at the center, I'm going to have to write this down, of a unit circle that subtends, I might just have to explain that word in a second, subtends an arc length of 1 unit. Okay, 1 radian is the angle at the center of a unit circle. There it is there. That's the center of a unit circle. Unit circle being a circle with a radius of 1 unit that subtends an arc length of 1 unit. This is called subtending. This angle here subtends that arc length because, you know, these radii make that arc length. So that's what subtends is all about. Okay, write that down. That's a radian. So let's now think about what, therefore, that means in terms of a conversion from degrees to radians, because we're going to need to be able to work between the two. So, conversions. Let's have a look at conversions. Okay, so if what we want to do is work out if that's 1 radian there, what is it all the way around? What's it going to be? What's that going to be? So if this angle here is exactly equal to whatever my arc length is, so in other words, if I go out now, if I went out here, so if I drew so if I extended this blue line and went two units around and closed it off there, that would be 2 radians, right? 3 around, 3 radians. Well, how far do we go around this unit circle? How far does this blue line extend? What is it? That's the question, isn't it? So how far do we get around? So that's 1. What is it? All the way around. Back to the starting point. What's that? Because that's how many radians I'll have at the center. So what is that's the circumference, isn't it? My circumference is equal to, what do we know it to be? 2 pi r. Hopefully you know that. 2 pi r. 2 pi r. R is 1. So in this case it's just 2 pi. My circumference is 2 pi. So this is 2 pi. So if it's 2 pi all the way around, then what do you reckon my angle at the center here is in radians? It'll be 2 pi radians, won't it? Because remember, the arc length and the angle at the center in radians are the same on a unit circle, right? So my 2 pi radians, so we can say therefore that 2 pi radians is equal to what we know to be 360 degrees. So that's what we can say therefore is that pi radians is equal to 180 degrees, and for the purposes of conversion, 1 radian will equal, what are we going to have to do? Divide by 180 by pi. 180 over pi degrees. If we go the other way, let's go the other way, 360 degrees is equal to 2 pi radians. Right, and 180 degrees is equal to pi radians. Right, what's 1 degree? We're dividing by 180, so it'll be pi over 180 radians. So there's our little conversion. So if we've, say, got convert, this is an example, convert 80 degrees, oh no, let's just go with a simple one, 60 degrees to radians, then we will take our, 1 degree is equal to pi over 180, so 60 degrees will equal 60 pi over 180, which reduces, doesn't it, to 1 and 3, so it reduces to pi over 3 radians. It might be more simply thought of as 180 degrees as pi, and that's 1/3, so 1/3 pi or pi over 3. We could say that 90 degrees to radians, and you might think of that as, well, 180 degrees is equal to pi. 360 is 2 pi, remember, just keep that in your head. 360 all the way around is equal to 2 pi r, being the circumference of a circle. So 90 degrees will equal pi over 2. So these are the conversions we need to make. What about the other way? Convert 1.5 radians, 2 degrees. Right, not so easy. So we'll go 1.5, what have we got to do? 1 radian is 180 over pi. So 1.5 rads is equal to 180 over pi times 1.5. Okay, take 1.5 as 3 over 2 and do a simplification that way. 1, 2 there, 92 is there. So it simplifies to 270, 90 times 3 over pi. Or you could write it in as a decimal as 180 over pi times 1.5. This is 1.5 radians, and you get 85.9 85.9 degrees as 1.5 radians. Okay, so there's just a few examples. We can get some more practice in our textbooks at exercise 16A. So we'll attack that next. Cheers.